Biomedical engineering is a multidisciplinary field where the principles of design, engineering, biology, and medicine converge. Here, in these labs at NUS, our faculty and students apply cutting-edge scientific research and design engineering to develop world-leading technologies and innovations that advance medical care.
The NUS Biomedical Engineering program provides a unique, integrated learning experience that synergizes our common curriculum of design and engineering with biomedical and clinical technologies and challenges in the healthcare sector. As a student, you will learn from and work alongside professors from the College of Design and Engineering, doctors and clinical teams at the National University Hospital, and with communities with special needs to develop compelling and innovative healthcare solutions.
NUS BME promotes a holistic approach throughout the 4-year-long program. Students can expect a world-class education that integrates engineering, medicine, and biological sciences, while having the flexibility in choosing their own path as a biomedical engineer and pursuing their interests and passions.
As a BME student, you enjoy a good balance of structure and autonomy. In the first 2 years, students are given solid theoretical foundations, whilst in the 3rd and 4th year, you have the chance to explore your interests and try your hand in more hands-on practical project-based technical electives. For my own project, I'm collaborating with the Singapore Sport Institute to develop a training system for our national footballers.
In the Biomedical Engineering department, you will develop key industry-relevant skill sets, covering from biodesign, germ technology, nanomedicine to biosensors, biorobotics, and AI. One major highlight is the medical device design course, where you will learn about biodesign process and how to design and make your first medical device.
NUS BME builds engineers who can contribute back to society, equipping them with a strong foundation suitable for a wide range of careers. This includes research engineers, hospital BME engineers, regulatory specialists, clinical trials coordinators, medtech entrepreneurs, as well as doctor engineers through the engineering and medicine track with Duke NUS Medical School.
At NUS BME, you'll see the passion and commitment of our staff and students to advance healthcare technologies. Faced with the challenges of the COVID-19 pandemic, our department has stepped up to meet the needs for rapid detection kits and optimal combination therapy for patients infected with the virus. Join us and be a part of our quest for the betterment of global healthcare for all.
Hi, my name is Ray. I'm the Deputy Head for Outreach Industry at the Biomedical Engineering Department in NUS. So I'd like to take this chance to share with you about a program of how we harness the power of biomedical engineering to really innovate and impact lives. Right, so as we know, biomedical engineering is a highly cross-disciplinary field that stretches across 30 different medical specialties. And you can see here, the discipline actually translate across fields like diagnostics, like cognitive stimulations, to digital health, to wearable robots, okay, or even tissue engineering and brain imaging, as well as assistive devices and nanotechnology. So this is a really growing field that allows us to really impact patients across different kinds of diseases. And of course, this centers around our building called the E7 Engineering in Medicine building. It is a world-leading hub for development of affordable and advanced medtech. And over here in this new building, we also see a reimagined curriculum integrating AI, digital health, robotics, and empathetic engineering alongside some of the core biomedical engineering topics. And why choose NUS BME? We are actually connected or deeply connected to the 3 major healthcare clusters. Right? We are also connected to the medical school in Duke NUS. And we have 2 major initiatives, the Be Good and Be Global initiative, which I'll explain in the subsequent slides. And very connected to the 4 distinct research institutions within NUS, Wisdom, N.1, iHealthTech, and the Advanced Robotics Center. And the program is also heavily linked up with the BME-related companies. Over here, we have over 100 companies that are connected to our program. And we're also part of the distinct health district initiative or national initiative within Queenstown. And our program is also very unique. We are looking at some of the very emerging topics like soft robotics, like gene and cell manufacturing, designing food through tissue engineering, serious games. Right? These are all very emerging topics. And then we're also looking at topics of medical robotics, assistive technology that actually brings a lot of technology, and automation to improve the quality of care. Maybe I'll just spend some time to talk about Be Good initiative. Okay, this is a strategic initiative to build empathetic and engineers leaders through community-driven learning in BME education. This is where we have a series of courses where students actually participate into project groups, and they talk to community partners, okay, and then learn from the elderly, from patients, or even individuals with special needs on what are the issues that really affects their quality of life. And this is where they come up with co-created solutions. And as you can see here, we have a huge database of solutions that the students have created over the past 4 or 5 years. And of course, this initiative has gone global. Okay, in the past 2 years, our students have stepped out of Singapore to make an impact in some of the regional communities, for instance, Timor-Leste. Right, our students went over to fix some of the medical equipment. They provide training for the healthcare workers. They learn about some of their issues that are facing for their healthcare system. And they actually brought some of these problems back home to actually design prototypes that can help to resolve these issues. And of course, within this Be Good framework, we have students, at the end of their courses, they actually went to the community to do their presentation, to do exhibition, and then showcase their very wonderful innovations to the elderly. In this case, as you can see, an excellent gaming project that actually got a lot of the elderly very excited about digital health. And here we see the majors, minors, and specialization. This is something a lot of our students are, we do see a growing pool of students moving into this area. If we are looking at popular second majors, we have the innovation and design, data analytics, and life sciences. 1 in 4 students actually have a second major, and then we have students, getting into this area, subsequently, joining DSTA to design or to operate robots that can enhance human performance. And looking at popular minors, we have life sciences, data analytics, and computing. Okay, almost half of our students have a minor. Right? And then this is where, having some of this, for instance, having computing skills allows the students to develop some AI competencies, okay, especially in developing tools that helps with surgical procedures. Specialization, if one doesn't have a second major or minor, usually the students will go into specialization. And this is where you can specialize in robotics, tissue engineering, biomedical materials, or even community healthcare and technology. So 1 in 3 of our students have a specialization, and almost a quarter of our students either specialize in robotics or tissue engineering. And many of those who specialize in robotics, they actually intern in robotic startups as well. Here we show you some of our interesting student projects. Okay, we have students who went on to develop a non-invasive glucometer, right, and then won a prize as one of the national competition. Okay, we have students who have worked on building the rehab board, basically a gait training robot that helps patients with Parkinson's diseases, and this is also part of the Be Good initiative. Okay, we also have another group of students who went on to develop a low-cost biopesticide for food security. Right, then they have went on to the international platform and really secure many awards at that platform. If you were to wonder about the career prospects, okay, we do have BME professionals really gathered around the whole medtech or the huge medtech ecosystem. Okay, in this case, we have students who are alumni who has went on to work in public hospitals as hospital engineers. Okay, they are also working in government agencies to help to run some of the national level policies or initiatives. Okay. We also have alumnus who went on to take up leadership positions for strategic partnerships, for instance, in SGH. Okay. We also have professionals who are more into the private side, okay, for instance, in medtech, in IP, regulatory, or even R&D, venture capital. Okay. As you can see here, alumni working as a regulatory consultant, working as a research R&D head, okay, or even being part of some of the major MNCs like Medtronic, okay, like Illumina, working as their head as well as a staff scientist, okay, or even with Biomedia Holdings, working as some of their corporate strategy expert, right? Okay, we have BME professionals after completing the undergrad program, they decide to really level up their skill sets or deepen their skill sets. So we have students who after finishing the program, they went on to explore programs in the top institutions around the world, for instance, Stanford, Harvard, MIT, okay, as well as Caltech. We also have students, after finishing our undergrad program, they went on to do a doctorate in medicine, okay, with the Duke NUS Medical School. And we do have a lot of cases around the alumni in the Duke NUS program. Right? As you can see on the right-hand side, clinical experts that have evolved from our BME program and subsequently a Duke NUS program. Okay, like they are all working as healthcare professionals, doctors or surgeons in SingHealth, NUH, etc. Okay, of course, we do have also another growing pool of students who went on to be entrepreneurs. Okay, like one of our very highlight story is Jeffrey, who went on to develop PetSnap, which is now a unicorn company. Right, we have Sean, we have Tian Tian, Hong Kai, who developed some of these technologies during their time in our BME program, and then they went on to spin off devices for pediatrics, for hospital food assembly, as well as rehabilitation. And of course, that's not all. We have another 12 other startups in the ecosystems that is also creating innovations that is improving the quality of care for the country and also for the world. So do scan our QR code to find out more about the program on our website, and also to have more information on the admission procedures. And I also encourage you guys to also scan the Telegram QR code so that you can be part of the chat group where you can ask a lot of questions about the BME program. There are seniors as well as staff on board who can answer your queries. Thank you.